Yeah, guys.
This conference will now be recorded.
Yeah. So we have been discussing about the functional programming of Scala. So let's continue that part. The functions, various types of functions. How do we declare them? How do we use them? Let us explore more into that part. Okay. So we have seen the last session. In one last session, I think the before that session, how to create a function and how to use it. That we have seen. Let me just give a quick review of that and continue with that session. Okay, continue with the concept that we have been discussing. Fine. Okay, first I'll create a function. So already we have seen how to create a function. X colon int, let us say this one parameter x plus 20, something like this is a function. And I can write one more function while f2 equal to, I'm passing multiple arguments to this function. Y colon int implies x plus y by x minus y is another function. I use one more function df f3 not df val f3 equal to I'm using something called as x colon some string y colon int, and here pass x plus y dot to string. Just I'm simply performing some basic operations and trying to use these functions. That's it. Okay, this will be another function. So the first function x colon int implies x plus 20. It doesn't have any name. Okay, so as it doesn't have any name, it is simply called as some anonymous function. Okay, and second function val f2 equal to this part. This is a function, right? Okay, and what is this f2 is acting as? And sorry, I take the same thing, right? Let me take like this df and val some a colon int equal to some 35. Okay, yeah guys, what is a here? What is a? It is a reference, right? It is a reference to what object? It is a reference to integer object of integer class. Okay, it is a is acting as a reference to object of integer class. Remember that point. In Scala, there is no concept of primitive types, complex data types, everything is an object. In Java, we have the concept of primitive data types, integer, float, double. They are called as primitive data types, and string and array. All these are called as what, complex data types. Okay, string is not a complex data type. Array and list, all these are complex data types. But here we do not have primitive data types and complex data types concept. Everything is an object. Okay, so a colon int equal to 35. Int is also an object. Integer, even though if it is single value, it is stored as an object. So a is acting as a reference to the integer object. Okay, similarly, if you see here val f2, what do you think f2 is? So if we have something a here val, and if we use var some b equal to some, let us say scala, sorry, some scala. So what are this a and b here? This a and b are references. Okay, so we create references or we create variables by using the keywords val and var. We have seen already. Similarly, here we are using val for function for this f2. So what is f2 is acting as? It is not acting as any name. Okay, it is acting as a reference to. So if this is if you are using something a and b, where a or val b something value like this, what they must be references to the objects, isn't it? They must be references to objects. Similarly, f2 in this case, the f2 is also acting as a reference to, it must act a reference to some object. Okay, it must act a reference it must act as a reference to some object. So remember here, this function is also getting created internally as an object. The function definition or the function, this function also is getting created as a as an object, in memory. So that is the reason we are using here val f2, remember. Okay, and with this statement, what's happening here? With this statement, f3 is not acting as a reference. Okay, f3 is becoming the name. F3 is becoming the name of the function. Okay, as we are using the keyword def, it is f3 is acting as the name for that function. Okay, this is called as a named function. Okay, this is, we are not assigning any name to this function. Simply we are, for this function we don't have assigning any name. Even for this function we are not assigning any name. Such functions are called as anonymous functions. But here we do not have any reference to this function. Okay, but here we have a reference to this function. But here f3 is not a reference. F3 is acting as a name for the function. Okay, x colon int and whatever the function it is. Okay, so if you're trying to assign a name to a function, those functions are called as what? Named functions. And if you don't have any name to a function, that will be called as an anonymous function. Okay guys, okay, remember, even we can have a reference to not only just, we can have reference to what? A reference to an object. Remember, a reference to an object. So if you are using val here, val f2, even this will be created, function will be created as an object internally. Okay, you have to understand this point. Okay, function also can be created as an object internally. That is the reason here we, if we could use val or var, so that means that it is, we are creating a reference to an object. That's the meaning of it. Remember, simply like that. Okay, so we can create simply like this, without a reference or without any name. We can create with a reference, or we can create with a name. In three different ways we can create the function. Okay, is it clear guys? Now, uh, f2 f3. So if I am trying to use f2, how do I use this function? How do I implement this function? How do I pass parameters to this function? Just let me write all this once again guys. First you have to understand guys, how we are writing all these functions. You have to understand. Val f2 def f3 def, some f4 colon a colon int comma b colon int equal to val p equal to x plus y, val q equal to x minus y, val r equal to x into y, and finally p into q into r. Something wrong. Sorry, not x, y, and y. They are a and b, right? Sorry. 4 equal to a plus b. Val q equal to a minus b. Val r equal to a into b. And finally p into q into r. That's it. Okay, now? It's clear, guys? Just let me write everything once again so you won't get confused. Val p first, q next, and r, and finally p into q into r, and close this. Okay, next I have written this function. Let me write that function also. This is one function, and def f3, val f def f3, where is it? Yes, it is here. And finally I can write x colon int implies x plus 2030, something like this. Okay, see the difference guys. In how many ways we are we are trying to create a function. See, just observe clearly here. Okay, d have f4, f4, f2, f3. It doesn't have any name here. This is a reference. F2 is a reference, not a name, and f3 is a name to a function. F4 is also a name to a function. All these are called as the different functions guys. Okay, any question in this guys? I've written different ways of writing the function.
Yeah, sir.
Yeah,
Sorry,
yeah.
doubt.
Hmm?
We are defined only two. We are defined only two integer.
Mm, mm,
A int and B int.
mm,
But here we are taking three, P,
mm,
Q, and R.
mm.
Then how, sir? Can you repeat one more?
No, we are taking the values A and B. Okay, we are passing
Yeah,
A and B,
yeah,
and we are
yeah.
computing the values. We are performing the operations on only those values, right? A and B are taken as taken as input. This one input. A and B is, is called as input, and we are performing the operation on A and B only, right? And we are storing the result into P. We can take inside the function we can create the variables. Okay, we can create the variables internally in the function also. Okay, so it is not always that what exactly the your doubt, Mantosh, here is okay.
Actually, sir, my doubt is here. Actually, we are defining three variable here, P, Q, and R.
Hmm. Okay.
We mention A and B there, only two in
No,
F4.
we can have any number of variables. We can have any number of variables inside the function. These are called a PQ or are called as a local variables. These are called local variables, and even we are called local variables. They belong to this function. So the scope of we can create a new variable inside any number of variables, not just PQ or only three, four. We can create any number of. Okay, that doesn't
Okay,
make.
but we are calculating only A and B. That's
Hmm.
why, no?
Yes,
Okay, okay, no issue.
we can create any number of variables or we can do any computation. Okay, so that computation must be carried out based on the values of A and B. Why? Because we are passing only A and B values. We can't, for F4 we can't pass PQR values. We can pass only the values of A and B. There is only two integers. So based on this PQR getting derived from A and B only, right? This PQR getting derived
Yeah,
from A and B only. So there is no problem at all. We can create any number of variables like this. Just I am writing some simple logic here. That's it. Okay. So
yeah,
F4, how shall I pass the data to this F4? Simply I call this function by using the function name F4 of some 2 comma 3. So what has to be result now? 2 plus 3 into 2 minus 3 into 2 into 3. That has to be the result. So 2 plus 3 would be equal to 5 and 2 minus 3 equal to minus 1. So 5 into minus 1 plus into uh, 2 into 3 6, so minus 5 into 6, that would be equal to minus 30. It has to give minus 30 as the result. So for this function, okay, so it is taking two integers as input, okay, and it is giving one function, one integer as output. Okay, now similarly if you see this one, this function f2 equal to, it is taking two integers as input and is giving one integer as output. We can see the function definition, function signature here. This is called function signature. Okay, int comma int, it takes two integers and returns one integer as output. Similarly this one, the function df3. So let me use f2 here. How do we use f2? How do we pass the values to the function f2? Is simply we can use the reference of it, f2 of some 4 comma 5. What has the result, guys, here? 4 plus 5 by 4 minus 5. This is 9 by minus 1, that will be equal to minus 9 only, I think. Let's sorry, so we can't divide, okay. So minus 1 can't divide 4 plus 5 by 4 minus 5. What is the result, guys? 9 by minus 1, is it equal to 0? F2 of 4 plus 5. No, let me write like this. I think it is getting, the first preference is going with this, let me use like this. So let me separate these expressions. I get minus 9. Okay, so we got 0 here. Earlier we did not use these braces here. What could be the reason? Yeah, guys, what could be the reason for this? Y by x.
is using
So
what?
yeah, first it is, yeah, y by x is taking the precedence. So it's taking the first precedent. That is the reason we are getting the value as y. Okay, that's fine. Next, how do we pass the values to the function f3? Directly by using the function name f3 of some. We need to pass an integer and a string. The first input has to be string and second input has to be uh, you know registering. Okay, so first let me write scala. and let me write some 3. It is an integer. So the result I have to get it as what? Scala 3. Simply I have to get scala 3. So 3 is getting typecast as string here. See the logic here. This is the logic. We're passing string and integer. It is getting created as function. Sorry, getting converted into string, and they're getting concatenated. When we use plus between the string, that is going to perform concatenation operation. Okay, but how shall I pass the data to this function, guys? How shall I pass the data to this function? We do not have any reference, or neither we have a reference nor we have a name to that function. Then how shall we pass the data to that function? So we can't directly pass the data to that function. So that is the reason it's always advised to specify some name. But even it has its importance, guys. Even it has its importance. I will try to show you in this session itself, now itself, how it has that importance. Okay, but it's better if it is out of, if it is independent. If the function is independent, always try better to have a name or a reference to that function. Okay, but in this case I can take res12. Why? Because it is going to create a reference internally, that is called res12, but it's not advised to go as it is repl as an interactive scala programming. I can use res12 for as a reference to this, but in a batch program we can't take like that. Okay, so I can use res12 of some integer, right? Some 20, so it has to give 50. Okay, array is 12, result 12, that's the meaning of result 12. So for this I am passing an integer, so it is giving x plus 30, thus 20 plus 30 equal 50 as the output. But it is not recommended to these functions to be written like this without any reference or without any name. Why? Because we can't use them. If you want to use it somewhere, then it is advised to go with a reference or a name. Okay, guys, right? Now I will show you something. Just see this. So these functions I told you, what are these functions now? This is anonymous function and this is a named function. Okay, now I will try to show you one more function. Okay, let me show you that. What I do is here, see this. F2, where is F2? This is F2, right? Yeah, fine. Now what I do is just observe. Def F5 equal to, just observe clearly, guys, what is that I am doing here. A colon int comma b colon int comma some c colon int comma int implies int implies c of a comma b. Just try to analyze this, guys. What is that it is doing? This we are trying to create a function. Okay, this is a function. Total, this is a function. So how many parameters we are passing to this function, guys? How many parameters we pass to this function? A is one parameter, okay, and b is another parameter, and a is integer object, b is integer object. And what about c, guys? What is this? What is this c? What is the type of c here? What is the type of c? Is it an integer, is it a string, or is it anything else? What is the here? The type of a is integer, type of b is integer, and the type of c is a function. Okay, c is an object to a function of this type. So what is the type of the function? That function should take two integers and return an integer as output. Okay, so that function should take two integers and should return a function, one more function, sorry, not one function, one integer as output. Okay, now that is what we are passing. So this is a function f5. For this entire function we are assigning a name called as f5. Okay, and internally for this function is taking, you know how do we, I told here we have f2, right? Here we have f2, and what is this? What a function should have, actually, how a function is defined? A function is defined as some set of statements, okay, uh, by reading some input, and it has to give some output. By reading some output, it has to give some output as the result. Okay, so if you observe this here, whatever that I have highlighted here, so it means that it is taking two integers as input and it is doing some operation, it is implementing some logic, some business logic, and giving one integer as output. Okay, this is called as a function. Okay, this is how we declare a function. So here the C is referring to a function here. C is referring to a function here. Int comma int implies int. Okay, I will show you now. Just wait, I will show you how this is used, where this is used. Okay, but remember, C is referring to a function. That means A is referring to integer, B is referring to integer. No, you can take like that. Okay, you can take like the why not here B. Even you can take simply like this. You can take a function, one more function, or just let me finish up this. I will come to that. Okay, so a colon. No, what I'm telling is, you know general till now we have seen only we are passing single value objects. Okay, integer, string, something like that. Okay, only single value variables or single value parameters. But I am trying to show here that we can also pass a function as parameter to a function, again one more function. So we are defining a function fi here. Okay, for this function we have three input parameters. First parameter is integer, second parameter is integer, and third parameter is not an integer, it is a function. Okay, so a function for which we pass a function for which if one of the parameters is a function again. Okay, so fi is the function here, it is taking one more function as its one of the arguments or parameters. In this case, fy will be called as higher order function. Okay, yeah, fy is called as higher order function. A function if it's one of the parameters or one of the arguments is a function again, then that function is going to be called as a higher order function. Okay, then what about these functions? These functions are called as simply normal function. We can simply call them as normal functions, or if it named function, otherwise RMS function, but it's simply a normal function. But this is called as higher order function. Why? Because this f2 is called as a not is not called a higher order function. Why? Because it is taking simply integers as input parameters but not a function. So if it takes a function as input, then that will be called as in higher order function. Okay, fine guys. Now see this, how we are going to pass it, how do we are going to pass the data to it. So fi of 2 3, and what has to the third parameter guys? Third parameter has to be a function. Okay, function of what type? The function should take two integers as input and should give one integer as output. Two integers as input, one integer output. Do we have any function like that already created guys? Do we have any function like that which is taking two integers as input and giving one integer output? Do we have any function like that already created? Do we have any function like that already created in the screen? In
Yes,
this,
sir.
yeah, what is that? F2, F2,
You have to.
F2. You are see this. Okay, so what is the logic getting implemented here? Yeah, we F2, F4, yeah, F2 also. I can pass F4 also here. Even F4 also it is taking two integers as input. I can pass F4 also. Got it now? So any function which is taking two integers as input and giving one integer output, that can be passed as an argument to this function. So now here fy is called as higher order function, and f2 and f4 are called as what normal functions. Okay, this is called as this is a difference between a higher order function and a normal function guys. Okay, you got the idea, right? How to create a function and how to create a normal function with reference, without reference, with name, without name, and higher order functions. Is it fine guys? Do you have any questions in this? I'll try to show you one more way of writing a function. That is the reason I'm saying that. Is it okay? Fine now, right? Now I'll try something. See this guys now here. Um. Okay. Let me use this f2 now here. Def f2. Fine. Now see that I'm trying to do something here. Def some f. Let me take it as some f1. x colon int comma y colon int mm, colon int equal to mm, x plus y. Right, like this, guys. I'm not using this braces here. This is same as this one, guys. This is same as. So as we have only one statement, we can write it directly. Don't get confused with this, okay? So x plus y is only one statement here we have. So if we have only one statement in the function body, then simply we can write it then and there is without any braces. So don't get that. So I wrote the complete elaborated way of writing that function here. Okay, both are same. Don't get confused with that. Okay. Now, just observe now here. What I'm doing is df m2 x colon int and y colon int equal to x plus y. Just observe this, guys. What is the difference between this function and this function? What is the difference between these two? You can see that now x and y, they are passed as a single input argument, single input. So even though we have two parameters x and y in m1 here, I'm talking about m1. I'm talking about m1, okay? X colon int and y colon int. Okay, so here the input is made up of two integers. That's fine, okay? But it is passed as single input. And if you see here, you know, x colon int y colon int. Okay, na? So here we are passing x and y as individual inputs, individual input parameters. You got my point here, individual input parameters, but not as a single input. So for m1 we can call it as only one input is there, but m2 we can call it as it is made up of two inputs, x and y. Okay, this type of convention, the second m2 type of convention can be used to make that function, to use that function as a partially applied function. I'm repeating the statement, partially applied function, to make it as, to use it as a partially applied function. Repeating the statement again, to use it as a partially applied function, we can go with this convention of providing the input. Okay, what do you mean by partially applied function? Let me come to that. So for, if I want to call m1 here, how many integers I have to pass? We need to pass two integers. Okay, it is best part two integers. But for m2, need not to pass two integers. Need not to pass two. We can pass only one integer here at a time. See how we are doing this. M2 of sum 4, it won't accept here. But for what about the other value? What about the other value? We are passing one value for M2. We need to pass another value also, right? So we can just skip it by using underscore. Now it is going to create one more function here. This type of usage of the function is called as partially applied function. Partially applied function. Got it? Are you able to understand this, guys? M2 of 4. This type of convention, don't get confused, is very simple here. We are trying to create x colon int y colon int as a single input, guys. Okay, so for m1 compressor we have to pass two integers, but with this convention we can skip one part. We can skip one, what you call as one input parameter. We shall skip it. We can skip the, just I have shown you here. For m1 compressor we have to pass 5 and 6. For m1 we can't write like this, m1 comma 5 underscore. This can't be done like this. The compressor we need to pass two parameters. Why? Because both are created as a single input in this case. But m2, the x and y are created separately. They are created separately. In this case we can pass only one value and we can skip another one. This is not going to return anything. So only after passing two values only we get the output for this. Okay, let me show once again. Let me the function x plus y. Now how shall I call this? How shall I pass the data to this function? See this, it is 4 and we need to open one more brace and pass the data, so it is going to result give the result as 9. That's okay. Okay, but if it is m1 like this, m1 x plus y, so for this we have to pass the data like this, 6 comma 7. See the difference here, how we are calling this function, how we are passing the data, how we are calling and passing the data to this function, and how we are passing the data to this function here. Okay, so if we have this convention, actually if we have this convention, the operation is different operation, that's what I'm saying. Okay, so what is that we are trying to do is we are trying to separate two input parameters. That's the reason, very simply we are trying to separate two input parameters, but in the function f1 we are combining those two. Okay, the function m1 will be called only by passing, only by compulsory by passing two parameters, but m2 can be called skipping one value. We can pass first element, we can skip the second value. Got it now? But see this, let me show you one more here now. See this, m2 of sum 4 uh, dot apply sum 5 uh, not apply, sorry, underscore m2 of 4 m2, yeah, m2 of 4 dot one second guys, yeah, it is creating a function. um, One second guys, m2 and x plus y, next m2 of 4 comma 5, that's, sorry, 4 and 5, that's fine. Next m2 of 4 use underscore, so we are going to skip one value here, so it is creating a function here. Next, one second, let me use like this, let me get one more function, df m3 equal to some a colon int implies int implies a plus some 20. No, it's not like that. mm, mm, m2 of 4 and followed by mm, next, what is the function I have to pass here? Okay, the address 29.5, that's okay, that's I can get directly from it, that's not a problem. mm, I'm trying to show you something else. How we can access, how we can, it is called as a chaining, actually chaining of passing the values. How shall I pass it? Just trying to see that. mm, Chaining, chaining, chain, chain. mm, mm, Missing parameter type for it, one second. Value applies not member of int. mm, just I will show you this guys, don't just to worry about this, just remember this, we can create a function like this, and this function we are trying to use it as, partially applied function. I will elaborate this in the next session, because I have some doubt here. Okay, Now just I show you that we have anonymous functions and named functions. And what is the, you know, is, do we have any purpose with this anonymous function without any name, having any name? Okay, let's try to see this now. While a equal to array of 2 3 4 5 6, we are creating 5 variables, so 5 values for in that array. Now a dot map of x implies x plus 30, x implies x plus 30. Okay, now I can also use these braces, not a problem. I can use these braces. So if you have only one statement, either we can go with 1 or we can go with 2, x colon int. I can use like this. The result is same, guys. Okay, now see this. What is this, guys? This or this one? What is this? Is this a function? Yes, it is a function, right? It's a function. What type of function this is? Is it a named function or anonymous function? It is an anonymous function, right? We are not giving any name. We are not assigning any name to this. This a dot map of this bird. And what about map here? What is this function map? What is the function map? Let's say this. Yeah, built-in what? Built-in what? Built-in. It is a function again. It is a built-in function, right? So this map is a function which is taking, further we are passing another some function as input again, right? So this function is taking one more function as input. Do you agree with this? So this map is taking one more function as input. So what shall we call this map as? What type of function we can call this map as? Can we call it as higher order function? Just now we have discussed, right? A function which takes a function as input, that can be called as a higher order function. So shall I call this map as higher order function? Yes, obviously we can call this map as a higher order function. Okay, that's what I'm trying to show here. Okay, so here for this to for this map function and all filter, no, not yeah, you know in this case, in the sense, what do you mean by in this case? Only in this case, I told that these anonymous functions, even though we do not have a name, no, not just with map, it can be with filter, it can be with flat map, we have many functions, right? So we can write like this: a dot filter of x implies x percentile to double equal to 0. This is a condition. Now even this is also a function, guys. This is also a function. So if you want to write it elaboratedly, I can write like this. Yes, in this case only. So if you want to write it elaborately, I can write like this. If you are doing the same, if you're trying to use the same convention, I can write like this: x colon int implies x percentile to equal to 0. So I can use like this also. So it is going to work like this. Got it? So even filter is also called as what? An higher order function. Similarly, I use flat map also. X implies x. So even it is what is it? Yeah, it is not a collection for gentiles. That's something like that. So while a2 will be called as a2 array of 1 2 comma array of 2 3 comma array of 3 4. Okay, now I can apply this flat map on a2. Okay, we got the values of 1 2 2 3 and 3 4. So simply x implies x. Even this is also what you call as, it is simply a function. So it is taking integer, one integer as input and one integer as output. That's simple, guys. Okay, so we can call all this, what in RDD programming we have been using all the functions reduced by key, different operations we have set functions. Okay, so all those are called as the higher order functions. Why? Because they take a function as input. Okay, so we have seen reduce by key, fold by key, aggregate by key, all these functions we have seen, right? Okay, so reduce by key, fold by key, and map, filter, all these operations will take only one function as input, but aggregate by key will take two functions. Do you remember that? aggregate by key will get 2 functions, and combined by key will take 3 functions as input. So if at least one of the parameters, is a function, that function will be called as an higher order function. So what are all the functional functions we have been using on RDD and Scala? Like this filter map, flat map, order by, group by, all these are called as the higher order functions. But we did not create this flat map or one. These are built-in functions. Okay, so for this we can pass any user defined function. So flat map is a predefined function here, and filter is a what called as filter is a predefined function. Map is a predefined function. For that we can pass any user defined function. Okay, for that we can pass any user defined function. That's how it is designed, guys. Okay, clear now? So about higher order functions and normal functions and how they are different. Okay, this is how they are going to be different. Okay now, guys. Now I will try to show you something. Just observe here. Class some A. I'm trying to create a class here. Class A. Val A colon int equal to 20, while some B colon float equal to 2.f, and what I'm running is df m1 of B colon int equal to a plus b, returning a comma b, a plus b, and I write like this: df m2 equal to, see this what I'm trying to show, different uh, declaration of functions in this class. M2 equal to a, or I can use some p colon int comma q colon int, returning some float. Let me return int only. Sorry, implies p plus q. Just let me close this. Sorry, 2.2, no, it is not dot. One second, guys. I'll be to f, that's it. M1 and a plus b. Next df m2. Let me take here also a comma b, guys. A colon int comma b colon int implies a minus b. Let me take a minus b. This we have defined a class here, guys. So if you use, till now in the classes we have used this convention, only this convention. Okay, so even we can use this convention of creating the functions also in a class. That's what I'm trying to show here. Okay, a colon int b colon int implies a minus b. We can use like this inside a class. Okay, now how shall I call these functions, guys? How this call these functions? You know now what shall I call about m1 and m2 here as functions or as methods? What shall I call this m1 and m2 as functions or methods? They will be called as methods. If the functions belong to a particular class, if you're trying to access them by using an object, if you're trying, if I pass something directly like this, m2 of 2 comma 3, m2 simply, if I pass 2 comma 3, do you think it is going to work? No, it is not going to work in this case. So compulsory we have to pass by using an object. First we have to create an object for this class A, and with the help of that object we need to pass the parameters to it. So how do we do it? Well, ob1 equal to, let me say, new a. Okay, this creates an object. New a is going to create an object, and ob1 is a reference to it. ob1 dot m1, so I need to pass the data to it. Sun2 comma 3 comma 3. No, so we have to pass two integers only, right? So ob1 dot of m1 of 2 comma 3 and m2 of 2 comma 3 is performing subtraction here. So this I'm trying to show that here we have been using only this convention in classes. We can also use this convention also in the class. That's what I'm trying to show, nothing else. So similarly, like we pass the data, like we call this method by creating an object for this class. Similarly, we can call this method also uh, by using what object here. Okay, object dot m2 of 2 comma 3. You can observe here. That's what I'm trying to show. So whether if the function is created, if the function we are trying to create outside the class, then it will call as simply a function. But if you are using, if that if that belongs to any class, that will be called as a method. Okay, what's the difference between generally a method and a function is? A function which doesn't belong to any class, but a function, if it is belong to a class, that will simply call as a method. There's no much difference. There's no difference in the declaration or defining the body, or how we are calling it. There's no difference at all, only whether it belongs to a class or not. That only makes a difference. What you guys, function and what you call as method. So try to remember these two. Okay, so higher order functions, normal functions, and partially applied functions, and usage of functions inside a class. This is a concept you have to know, guys. Okay, still we have something to know about this functional programming, but we shall try to see that in one, it will take 1 or 2 sessions still to discuss something about this. We have a new concept called as a function, concept currying function, currying, not currying function. The concept is called as currying. How do we use it? How do we use the partial applied function? That we shall discuss in the next 2 sessions. We shall discuss about all this. Okay, do we have any questions, guys, in the whatever discussion we have made here? Is it fine for you, or do you have any questions still? Yeah. Now let me show you one more simple logic here. Def some k1 equal to k1 a colon int some b colon string equal to a plus b dot to int. Do you think is it the valid statement, guys? Do you think is it the valid statement? It is valid. So what would be the elaborated version of this one? Let me show you that. Df the same elaborate. I'm writing in elaborated way. No, k1 of a colon int comma b colon string. Okay, and the result type is optional. So in the first declaration we have skipped our result type, so we are including result type. Because that is optional, we can omit it. So I have omitted there. Okay, don't get confused. That's why I'm trying to show both concise way and the elaborated way. Equal to, so where we have only one statement, we can skip these braces. If you want, we can use these braces. That is a plus b dot to int. This elaborate way of write, you can see this. This is same. Whatever we have, it is giving as output. The same output we got here: a colon to b colon string and int. That's it. So this is concise way. We are omitting the result type, and as we have only one function in the body, only one step in the body, we can write simply without using any braces. Okay, but here we are using these braces. We can follow any convention, that is same. Okay, don't get confused. That's what I'm trying to show here. Okay, now, and one more, df some k2 equal to, I can use this convention x colon int comma y colon int implies x plus y. This is a convention, and I can use one more. So if we do not have multiple step, what is the how many statements are there in the output now? Now this one input parameter, so not input, two input parameters. So this input is separated from output. So this is going to actually decide the output, right? So we have only one statement here. Can we have multiple statement, guys? Can we have multiple statements after this implies symbol? Can we use it? Yes, we can use. But if you have only one statement, we can simply omit this curly braces, and we can simply we can place this brace, non parenthesis. This is going to work. But if you're trying to go with, see this, x plus y, I'm writing like this. Val p equal to x plus y, and val so it is saying that we are trying to write one more function, one more statement inside this function. But in order to do that, we have to use curly braces. See, if you use curly braces, it is not going to throw any error. Okay, and I can write this now, val p equals to it will work now. So if you have multiple statements inside a function, use curly braces, guys. Otherwise, you can simply omit that, and you can write normal parentheses if we have only one statement. Got it now? Okay, so try to understand this difference. So don't get confused. These are simple differences. Why? Because in Scala we can some construct specifying something or indicating something is optional. Some in the writing the result type, and using the when to use curly braces, when to use normal parentheses, when to omit them. So we should have some clarity about it. Otherwise, we run into confusion. So that's what I'm trying to show. Okay, just to practice this, guys, the basic functionality, and I will try to show some programs corresponding, relating to this functional programming also. So how do we do that, how we are going to work it? Let's take some use cases, and we call these functions as pure functions also, pure functions which do not have any side effects. So what is that concept? Why they are called as pure functions? Why they do not have any side effect? We'll discuss that in the next session. Okay, guys, just I've shown you again how to create the functions, all the steps of functions. Just have a practice of this today, and tomorrow I will introduce you with some more concept of this functional programming. Okay, fine, guys. Any questions in this session? Yeah. Guys, let's wind up the Scala session for today, and tomorrow we shall continue. And get ready for the Spark session in the next 30 minutes. Okay. Thank you, guys. Thanks for your time.